The stage is yours.
Yeah. Thank you very much, the all the committee members, who have given me this pleasure to deliver a talk on my international journey, research journey on interdisciplinary research and diversity in science. So the topic of my presentation, I'm saying that you have already seen that lessons from an international research journey. So briefly, I will speak about my international journey. So about me, firstly, I will introduce myself. So I am basically from India. So this is the place Kolhapur, and in Kolhapur there is a small hometown, Mandalabuduk. I born in this at this place, very small hometown with 5,000 people population. So I graduated and from the university situated at Kolhapur, Shivaji University, Kolhapur, which is state university, government university, which is very famous in the state of Maharashtra. Uh, yeah, so here you can see the picture, the traditional wear Maharashtrian people from my state. So in India there are 28 states and 8 territories. So each state has their own culture, own heritage, and different means clothing or wears, traditional wears are there in every state. And we have different languages. Means each state has their own mother tongue. So more than 28 languages in India. So this is the culture about India. And this one is Mahalakshmi temple located in Kolhapur. So built in 7th century. So very old temple, Mahalakshmi temple, is famous in India. This fort, so Maharashtra is also known for different forts. In India, in every state, there are some forts are there for earlier emperors. So Maharashtra also have more than 10 to 12 forts. So built by the emperors at that time. And this is Salini Palace, which is built in 1931. It's situated in Kolhapur. Also, Kolhapur is famous for its non-vegetarian and vegetarian food. So the chicken curry, this red curry and white curry is famous in South India. So it is from Kolhapur. So the Kolhapur is rich in its culture, rich in its heritage, and it has a long history. So this new palace is also constructed in 1884. So and one thing is that it is Kolhapur is famous for leather shoe in the world. So first leather shoes, handcrafted leather shoes are prepared in Kolhapur. So it is known as a Kolhapuri shoe. And if you see nowadays in Prada, that is a shoe brand, they sell this shoe with their brand, and the price of the shoes is around $1,200 US dollar. But in Kolhapur, you can get it in less than $100. So that's the price of this shoe. Okay, so about me. So I finished my PhD in physics. So basically, did PhD in physics. I did master in physics, but I worked on material science. Means mostly I did PhD in aerosol materials. So my professor was working in aerosols. So I worked on aerosol materials. So it's basically material science. So this is a picture before 13 years when I was doing PhD. So these are my friends, so senior friends. So he is now professor at Queensland University of Technology, Australia, and some are working in South Korea and some are working in India, professors. So after finishing my PhD, I joined as a lecturer in basic science department at diploma institute. So after 10 plus students can join there. So I worked as lecturer for 2 years, and then following that, I joined as assistant professor in Department of Physics in Rajaram Bapu Institute of Tech. This is an engineering institute. So where I taught to the BTech students, undergraduate students in engineering physics, different BTech students from different backgrounds. So first year I taught them as a physics subject, engineering physics subject. And after this, I got opportunity to do a research. So continue my research in aerosols, and I joined as a Brain Korea attendant postdoc fellow in South Korea, Yonsei University, which is very famous university. Its world rank is around 50. So in top 50, this university comes. And I joined as a When Korea 21 postdoc fellow, and following that, I joined as a research professor in the same group. And there I worked in Yonsei University almost 9 years. I worked on the erosion subject. So the experience is during my journey as a postdoc and research professor at Yonsei University. So we developed one erosion material research lab. Previously, my boss in that Yonsei University, he was not that much famous of working on the erosion, but in this 9 years, 10 years, we developed a research center in Korea. That is number one research center, erosion research center in Korea. So we got some government projects, National Research Foundation of Korea project. So that is one center we developed in that university. And in 2025, I got a chance to join the SKCM2 recommended by Professor Smailuk. So I was in contact with him, working with him for the previous 2 years. So he invited me to join this institute. So I joined SKCM2 from 2025. So presently, I'm serving as an editor for different journals. So I mentioned here. So that's the thing. So we have to do some. We need to change in our life. So if you want to grow in your life, that is most important. So I did work with different background people, different means I work with students, 10 plus students. I taught to BTech students. Also, I work with some international researchers. So that is my basic background. And with this 13 years of experience, 10 years of after PhD, now I have almost 4,000 plus citations in my Google Scholar profile with 130 plus publications. So when I did PhD, I had only 15 publications, but now it's almost 130 plus. So what is diversity in science? So there are many words we need to keep in mind when we are doing the research or any interdisciplinary work or diversity. So these are some words. So diversity is a basic word included in all kinds of here. So you can see here the research is there, inclusion is there, diversity. That is very much important. So science needs a diversity. So for that purpose, what are the benefits of diversity in science? So we can create or innovate something new. We can enhance the productivity if there is diverse culture in the science, teamwork and loyalty, and we can stronger the publications or we can produce some good results. We can patentize our work or we can publish some good publications. So this is a photograph. Maybe everybody knows that. So very bold photograph. So interdisciplinary research. So this is general slide. So you can see if you are going to do any interdisciplinary research, you have to keep in mind these four things. So you should be, you have to do hard work. So before publishing any work, you have to do many different optimizations. Or suppose in material science, in my field, I have to do many experiments. I have to optimize the materials. I have to prepare the samples many times, and then I can get some results, good results. So while publishing the paper, there is a very much hard work you have to do. Then flexibility and openness. So if you are facing a problem, so you should be flexible. You have to discuss with your senior colleague or you have to discuss with expertise person in that field. Then you can get some good insights to produce a good result. So that is one thing. So interdisciplinary research should be problem centric and tool centric. These are two things when you do the interdisciplinary research. Okay. So in my case, the international research experience, what I already mentioned, I did my all the education like graduation, undergraduation, graduation, and PhD from Shivaji University, Kolhapur. So this you can see the campus, that is main building, administrative building of Shivaji University. Then I moved to South Korea, Yonsei University, South Korea, which is a very famous university. I worked here for almost 9 years. And now I joined Hiroshima University. This is also one of the good universities, in top world ranking top 500 comes. So I'm working now at Hiroshima University. So in my international research experience, after PhD, 10 plus years international experience I have with me. So I did research in India with different interdisciplinary research I did with Indian colleagues. I did research in Korea and Japan. So while doing the research in different countries in India, where I come from, Shivaji University, we had a lack of some advanced instrumental techniques. So when I joined Korea, I got to know some advanced instrumental technique. I handled some advanced instrumental technique. I myself did the analysis of the materials, and I characterize my materials. So that is the that what benefit I got from this international research experience. And I continued my research in functional nanomaterials, aerogels, and composite. Just I continued my topic as an aerogel, but in that I did some interdisciplinary. Means I used that aerogel for different applications. I calculated some surface free energies of the aerogel material, because aerogels are sometimes hydrophobic, sometimes hydrophilic. So I calculated some mathematical means surface free energy values for the material, so where we can use for different applications and extreme conditions. And I did some high temperature thermal insulation applications during my research journey in Korea. So different. I work on energy storage, energy conversion. So I use the aerogel materials for different applications. So basically, I started with silica aerogel, which is very fragile, transparent, mostly used for thermal insulation. Then I moved to different kind of inorganic oxide aerogels, organic aerogels, and composites of that materials with different kind of means organic inorganic hybrids. So that's what I did. And also the most important benefit, when I joined Korea, I started cooking. So I'm a good cook. I can cook different Indian foods. So that's my experience. So that is the thing, and I experienced some advanced techniques. So this is the first photo when I just reached South Korea in 2016. So I first means in my life, first time I enjoyed the snowfall, and for 9 years I enjoyed this snowfall and this cold weather, chilling weather in South Korea. And I got opportunity to meet our beloved Prime Minister Narendra Modi ji when I was in Yonsei University, South Korea. So he visited previously 2-3 years ago. So I got that opportunity during my this journey at Yonsei University. So this is my previous group, Professor Hingo Park from Yonsei University, South Korea. Now he's distinguished professor. He retired from professor position, and he's started some startup. So that is so he started a startup on aerosol materials. So he was previously doing working on physical techniques like ALD and CVD. So semiconducting materials or more transition materials. In last 10 years, we developed a lot on aerosols, and now his group is means one group means he's doing aerosol in South Korea, first group, and we have maximum facilities to prepare the samples in different formats. So we have different countries, researcher from China, South Korea, India. We are working together in this group. These are the instrumental facilities we developed at in Aerosol Material Center, South Korea. So from this research experience, I totally transformed what I was before 13 years at when I did PhD at Shivaji University, and when I worked with Professor Hingo Park at Yonsei University. My research experience means I got many new insights and many new ideas working on the aerosol material. Because when I started my PhD, there was one of my senior. Now he is scientific officer here in Bhabha Atomic Research Center. So he visited our lab, and that time when I was new doing PhD in aerosol, I asked him, there are many works already published in the aerosol, how I can start my work on the aerosol. But he told me that you have to search something in that, because there is some gap. So I started to find the gap, and I think that there is many there is a gap in the aerosol research. So we can do a lot in aerosol research. So overcoming the research challenges, two things. One thing you have to. So this slide explains it a lot. So without skill, we are doing a lot of work. One researcher can do a lot of work, lot of experience, lot of hard work, but he can't get a good publication or good results. And with skill, suppose if you are doing some good work, so in that case, if you are getting some trouble, you have to discuss with your professor, you have to discuss with your colleagues, you have to discuss with your friends. Then you can get some insights, and then you can produce a good result. So you can get some skills. So the PhD time or master degree time is the time when you can get the skills. That's what I got during my PhD time. So this degree is for getting the skill, and after that, that is your journey. So you can start to work. So in my case, when I was doing PhD, okay. So what I told Shivaji University is not means that time we have not that much developed. We have to work whatever instruments we have at that time. But now we got many new instruments and advanced techniques after this 10 years of my PhD. So it is very hard to obtain the advanced characterization technique like simple we can say transmission electron microscope, X-ray photoelectron spectroscopy, or some different analysis techniques. So it was very hard, but that time how I solved this problem, I communicated with my senior colleagues, my senior friends working abroad. So they were already doing postdocs in different countries. So I contacted them and they helped me to get that analysis technique, characterization technique for my sample during my PhD degree, or communicated with researchers with other institutions. So you can search the researchers who are working in your field or different fields with whatever instrument you want to use. You can ask them. They will not say no because they are always ready. Researchers are always ready to collaborate or to help someone. Okay, who are in need. So they helped me. So in my case, Professor Ma from National Dong Hua University, Taiwan, and Professor Stephen Mullins, he is in Belgium. Yeah, that is Vito Institute. So I asked him because I wanted to analyze my sample with surface area, BAT surface area. So at that time in my institute, that instrument was not there. It was in the other institute in India, but I contacted him and I asked him to for the analysis, and it was my good luck that he agreed and he provided the analysis for my sample. So I finished like this my works during my PhD. I published the results, and now in my postdoctoral career, I helped more than 30, 40 students to get some advanced characterization to publish their good works in good journals. So I'm still helping. During my postdoctoral research work, so I was working, I was synthesizing the aerosol. I had expertise to synthesize the material, but I don't know how to simulate. But I am from the material science background. I was good in experimental technique, but I don't know how to simulate the mechanical properties, how to determine the mechanical properties of the material, what I am going to synthesize or master in advanced scanning technique or published in high impact factor journals. I was producing the result, I was publishing my paper, but it was very hard. So I started to contact the international colleagues who are working in that field for simulation of my results or my work, and we publish the collaboratively. So I work with the professor from here, Germany, RWPS Aachen University, Germany, and Professor Michael Mio from University of Southampton, UK, and Professor Ivan Smailuk. Also, I have experience to work with Professor Kazuyoshi Kanamori from Japan, Kyoto University, Japan. So I just contacted the professors. We worked on our subject, and it was very fruitful. So we published a good works. So this just I want to explain you. So this slide shows you that this is one journal in our field, material science field, chemical engineering journal, which impacted is 13, more than 13. So it is very famous. So previously, before 2021, 2020, we wanted to publish in this journal. So that time we submitted many articles. So you see here, more than 15 articles is accepted, but we didn't stop. We never stopped. So we started to think on it, how we can get the publication in high impact journals. So we work on it and we solve, we found the solutions. And now presently I have more than 8 publications in the journal. So that is the thing. So you have to overcome the challenges when you are doing some research. So you have to think on it. So how collaboration started? So main purpose is we are doing good research, but we are not publishing in high impact journal. So we wanted to publish our research in high impact journals. So that time we started collaboration. So what is I started to find the gaps between my research. So I need some simulations to support my experimental results, or I need some advanced techniques. So that time we started the work, because just we were doing the work, but it was worthless because we are not publishing high impact journals, and that is not reputative in our field, material science field, people say. So we started to work on that, and we published the work in high impact journals. So that time is there, so we have to think on that, and we have to solve that problem ourselves. So there are different opportunities and challenges. So this photograph is during some conference in Vietnam. I was the special session speaker at that conference. So there are different opportunities when you do interdisciplinary collaboration. So innovation at disciplinary intersection, access to diverse expertise. So different kind of people, researchers are there. Real world problem solving. These are opportunities, and broader impact and research visibility when you do interdisciplinary research. And there are some challenges, so you have to think on the challenges also, and then you can get some fruitful results. Like last couple of days, you did group presentations or some fusion projects. So that is the interdisciplinary thing. So you have to manage, because there are multi teams or multi country research or some different opinion people. So you have to make it a team and collaborate together. Then you can get some good idea. You can produce a good idea in the interdisciplinary research. So in my case, how this collaboration or research direction started. So we started to think. So this is, you need to keep in mind, out of the box thinking. The people only think about their research. They are not thinking others, what they are working, what they are doing. So you have to think what other people, researchers, different background researchers, what they are doing. So you can get some insights from them, some ideas from their work. You have to literature review the articles in different fields. So that gives you some different benefits to publish or to do a good research. So this is about my interdisciplinary research. So I'm working on material science, but my work belongs in different fields. So I'm using the materials for different applications. It belongs in a different fields. You can see. So that's why. So this photograph is when I gave a talk in my alma mater, Shivaji University, 2 years ago. And just when I worked in Yonsei University, I just want to visit this place means more and more, because there they wrote Yonsei where we make history, and in my case, I make a history in Yonsei University, because I got many research articles, or I got many new ideas about erosion work, and I familiarized with some advanced instrumentation techniques at Yonsei University. So that is the history about me. So work-life balance. So the good quote is that how you live is how you live. So that is also important in your life. So work and life balance. When we are doing the research, or in our case in academics or in any field, is for researchers, work-life balance is very much important, because when you are doing some good, when you can do some good work, if there is some support, there are some people who can give their time, okay, to and pushing you to do some good work. So their sacrifices are very much important, so that you can do some good work, good result. So these are some pictures I am just showing. So in my case, the one good thing is that my wife is also PhD from my same university, 2 years junior, she's in physics. And last 7 years at MSA University, we work together. Means we were sitting in same office. So we were postdoc at same office. So my work and life, we were together. So that is that is the thing. So and this is photograph from my professors from my previous alma mater, Shivaji University, and you can see some photograph. I like to. I am from my parents are farmers basically, not very much rich. Just India is 70% farmers country, you know. So I like to farm. Sometime when I go to India, visit to India, I like to go in the farm. And so this is, you can see these are the sugarcane farming is going on. So sugarcane, these are there. So we have to just put the sugarcanes in the field. So that time I took photo. It's just 2 3 years ago. And this is about the mountains. So Sangwon Mountain, we just hike in Korea. And I was with my research, with my work, I was working for my community in India, for my state. In South Korea, I was the coordinator, and we were arranging different events for our community people in Korea. So I was one of the coordinator in that committee. And this is the photograph from Vietnam trip. So these are my lab colleagues from Korea, my wife, my daughter. Here, you also see my daughter. Okay. So this is also important work-life balance. Briefly about my research. So my first area of research already I explained. I basically expertise in the metal oxide aerosols. I can synthesize different inorganic oxide aerosols. I can synthesize carbon-based aerosols or organic aerosols. High entropy oxide recently started to work on high entropy oxide based aerosols. In my PhD time, I had experience to work on hydrophobic coatings. So you know that lotus leaves are floating on the water. That is Cassie-Baxter's effect. Okay, so that hydrophobic type of materials we used to synthesize hydrophobic films, carbon foam composites. So then, during my work at Yonsei University, I started different applications. Before I was working on only synthesizing aerosol, but when I started my postdoc, I started to learn the different application techniques and started to use my materials for different applications. So that I got the knowledge. So by learning from the researchers, by reading their papers, I started to work and I myself did different applications for aerosol materials. So there are different work we did when I was in South Korea, in Yonsei University, South Korea. So what I told, that is the Aerosol Material Research Center. We had different kind of people like SKCM². We worked with different background in the, professors, and we had more than 40 people team to work on the different kind of research. So simulation people were there, application based professors were there. So we worked on that. Means during the work, my journey at AMRC, Yonsei University, South Korea. So what is aerosol? Just briefly, I will explain because just 3 minutes are there. So aerosol is a highly porous material. Aero plus gel, you can see. Many people know hydrogel. Okay, there is, but in case of hydrogel, there is a solvent. Water is there. Okay, but in aerosol, no any solvent. It's just the air. Okay, more than 90% solid means air, less than 10% the network, solid network. So basically, CPC considers silica. The transparent aerosols are mostly silica aerosols, and in that silica aerosols, less than 10% is the network of silicon oxide, and more than 90% air is there. So that's why it is highly thermally insulating. You can see. You can just put your bare hand on the surface of just 5 mm thick aerosol sample, and the burner temperature, you can see butane torch temperature more than 1300 degrees Celsius. So at the surface, you can only observe less than 100 degrees Celsius. That's the beauty of aerosol. It's a very lightweight and material, you can see, and surface area is very high. And you can see the surface area of aerosol, 10 gram aerosol sample is same like a equivalent surface area of the soccer field. Okay, that much area can be stored in 10 gram of aerosol sample. Okay, so that is the beauty. So you can see the pore size also. It's just 10 nanometer. So you can synthesize different materials, different kind of aerosols, mostly transparent aerosols. You can see transparent aerosols. Professor Smailuk and Professor Kanamori, they are working on this. They are using for window insulation. So thin slides of transparent aerosol they are preparing. This is one company, aerosol from USA. They are also preparing transparent aerosols for window insulation application. So this is from NASA. They are also working on different kind of polymer-based aerosols for space application. So this also we synthesized with collaboration with Professor Kanamori, transparent and flexible aerosols. And I worked on different fields. So these are explained in my review article. So we can synthesize silica, non-silicate, biopolymer, polymer-based aerosol, and different carbon-based aerosol for different applications. So we worked on different kind of, so that is interdisciplinary. So these are some publications we got. So just I noted few publications where we work on the theoretical with theoretical people and experimental people together for different applications of aerosol, and we publish papers in good journals, reputed journals. So these are samples what I prepared. Now I can prepare transparent silica aerosol, very high transparency, more than 90% transparent. You can see polyamide aerosol. I have experience. I can synthesize RF-based polymer-based aerosol. We can prepare carbon aerosol, hydrogen porous carbon aerosols, and so this aerosol is, see, I'm playing with the aerosol sample in my lab. Okay, so this can bounce. So mostly aerosols are fragile, silica-based aerosol. But what I prepared is using some different technique, epoxy tile polymerization. It is not that much fragile. It is very hard as compared to basic silica-based aerosol. Okay, it is not easily broken. And this aerosol I firstly synthesized. This is RF-based aerosol. Recently, we reported this work in Chemical Engineering Journal. So this sample is tough as well as flexible, strong as well as flexible. So it can regain its original dimensions after some time. You can see. Okay. So I prepared this first time with some new technique. So I am very much thankful to my collaborators from different countries, mostly from India, UK, South Korea, and Japan, as well as from USA, and Germany. Because of their collaborations, I got many new ideas. I worked on many new topics, and I focused on my research with some interdisciplinary approaches, and that's why we got some new ideas and we published our work in different journals. So like this, so this waterfall you can see. So interdisciplinary research is like this. There are different flows you can see, but after that you can see the point. So that is the beauty of interdisciplinary research. If you combine, join the research with some interdisciplinary research people, you can achieve some good results. Okay, so I am open for collaborations if anyone wants. Thank you. Yeah.